Today's lesson is divisibility and factors. The objectives of today's lesson is to use divisibility tests and to find factors. Vocabulary. One integer is divisible by another if the remainder is 0 when you divide. And 2, one integer is a factor if the other non-zero integer if it divides that integer with a remainder of 0. So they both have to be whole numbers, no decimals involved. Some key concepts you need to know, some divisibility rules. An integer is divisible by 2 if it ends in 0, 2, 4, 6, or 8. So a 2 will divide into any even number. Then there's 3. If the number of its digits is divisible by 3. So, if it's 1,250, 1,250, what you would do is add them up. 1 plus 2 plus 5 plus 0. And that would be 3, 4, 5, 6, 7, 8. 8. And then you would check and see if 3 goes into it. Well, 3 does not go into 8, so it would not be divisible by 3. And for 5, if it ends in 0 or 5. So any number, huge or small, that has a 0 or a 5 at the end, 5 will be able to go into it. 9, same idea as the 3. If the sums of its digits is divisible by 9. So again, you would add them up like here, and then instead of a 3, you would put a 9. And 9 does not go into 8 evenly, so 1,250 will not be divisible by 9. And 10, if it ends in 0. Any number that has a 0 at the end, that does not have a decimal, then 10 will go into it. So let's try it out. You're not going to do the math. I'm not asking for the answer. All I'm asking for is to see if it is divisible by the number that's given. So if I look at 567, is it divisible by 2? Well, let's look. 2 is talking about end numbers. So we look at the 7. Is this 7? This 7 is not a 0, 2, 4, 6, or 8, so it's not an even number. So you would say no. 7 is not even. B. 5 again, here we have a 5 at the end, this one right here, 5. So we look at the end number again, and we say 5, and I say yes, because 5 goes into 5. So you would say yes, and we say ends in 5. 3 is 567 divided by 3. Can it be evenly? Let's find out. You would go 5 plus 6 plus 7. 5 plus 6 is 11 plus 7, which is 18. Now, can 3 go into 18 evenly? Yes, it can. So you would say yes. I'm going to change the color because it's too close to the other blue. So you would say 18 is divisible. Div is fine, is by 3. D. You're finding out if 1,015 is divisible by 9. And again, just like C, you add them up. You go 1 plus 1 plus 5. You don't need to have the plus 0. We all know 0 is already in there. So we go 1 plus 1 plus 5 is 7. And can 9 go into 7 evenly? No. And you say 7 is not divisible by 3. 9. E. Well, 10, when you're finding out if something is divisible by 10, you look at the last number and see if it has a 0 on the end, and it does, so you're going to say yes. It ends in 0. F. That same number, 111,120. Is it divisible by 3? Well, let's find out. You go 1 plus 1 plus 1 plus 1 plus 2 plus 0 if you want to put it. So you go 1, 2, 3, 4, 5, 6. That's 6. Is 6 divisible by 3? Yes, it is. So you're going to say yes, and you say 6 is divisible by 3. Now we have to see if 43,542 is divisible by 9. Again, you need to add them up. 4 plus 3 plus 5 plus 4 plus 2. And that equals, let's see, 7. And that would be 12. 7 and 12. 16, 17, 18. 18. And does 18 go, does 9 go into 18 evenly? Yes, it does. So you're going to say yes. 18 is divisible by 9. And that's how you do examples 1 and 2. Example 3, list the positive factors of each integer. A, there are 20 students singing at a school concert. That's how I say students, STS. There are 20 students singing at a school concert. Each row of singers must have the same number of students. There are at least 5 students in each row. What are all the possible arrangements? So we first need to find the factors of 20. The factors of 20 are, I always write down the number, and then I write down a colon, and I write down the factors. 1 goes into 20 evenly, 2 goes into 20 evenly. Does 3? No. 4? Yes, it does. 4 times what? 5. Very good. 6 go in evenly? Nope. 7? Nope. 8? No. 9? No. 10? 10 times 2 is 20. And then 1 times what? 20. So those are all the arrangements of the factors that you can have. So let's go over the possible arrangements. Okay, so I know we want at least 5 students, so I know I can have 4 rows of 5 students. 5 students. What's another one? I can have maybe 2 rows of 10. 2 rows of 10 students. Or I can have 1 row of 20 students. Students. And that's how you would do that. You would have 3 possible answers. 10. We are going to find the factors of 10. Well, I know 1 can go into 10. 1 always can go into 10. Let's do the colon first. Can 2 go into it? It's an even number, so yes. Can 3? No. 4? No. 5? Yes, 5 times 2 is 10, so we're back down to only these 2 at the bottom. And then 1 times 10. So those are your 4 answers to that one. C, 21. I know 1 can go into it. 1 can go into everything. 1, can 2? No, it's not an even number. 3. 3 times what? 3 times 7. 7 might be the next number, but we don't know. 3. 4 can go into it? No. 5? No. 6? Nope. 7. 7 is the next number, so I'm going to bring 7 over just a little bit more. 7. And since 3 and 7 are your middle, so it would be 1 and 21. 31. Can 1 go into it? Yes. 2? Nope. 3. 3 plus 1 is 4. Nope. 4? Nope. 5? No. 6? Nope. 6 can go into a number if both 2 and 3 are going into it. And since 2 and 3 aren't going into 31, it can't be 6. 7? Nope. 8? Nope. 9? 3 plus 1 is 4. Nope. 10 doesn't end in 0. 10. Big chance there's no other numbers except for 31. This means it's a prime number, and that means only 1 in itself can go into it. Composite means there's more than 1 in itself that can go into it. 24. 1. 2. It's an even number, so yes. 3. 4 plus 2 is 6, so yeah. So it's 3, 4, 24, yes. 4, 5, no. 6. 4 times 6 is 24. So now we're going back down. So 3 times what will get you 24? 3 times 8. And then 2 times what will get me 24? 2 times 12 will get me 24. And 1 times 24. So those are all the factors of 24. And that is the end of this lesson. Goodbye.